Hello fellow Linux using MCU enthusiasts! Today I'm diving into the fascinating world of the Milk v RISC-V MCU, and trust me, you're going to love this adventure. Whether you're a seasoned pro or just starting out, this little powerhouse is a game changer for Linux users like us. So let's get started, shall we? First off, what is the Milk v MCU? It's a multi-core microcontroller unit based on the RISC-V architecture, designed to be versatile and powerful. The best part? It comes in two flavors, the 64 meg and the 256 meg versions. So, you may be thinking it's all about memory, right? Actually, the two versions are much more than differing memory capacities. They have different cores. Although not discussed in this video, both versions also include an 8051 MCU core, as well as a TPU core for rudimentary AI processing. The 64 meg version features two main cores, both of which are RISC-V. One core runs at 1 GHz and the other at 700 MHz. The 64 megs of RAM are DDR2. The 256 meg version has the same two RISC-V cores, but also features an ARM Cortex-A53 core. The RISC-V and ARM cores do not operate concurrently. There is a boot pin to select which core will boot and run. The 256 megs of RAM are DDR3 technology. The faster core is normally used to run Linux. It also serves as the interface between the chip and the Arduino IDE. It handles all of the upload protocol, leaving the 700 MHz core free to just run your Arduino sketch. Once the binary has been successfully uploaded and verified, Linux places it into the Arduino core and starts it executing. This faster core lets us use basic Linux commands and tools. The Linux kernel is installed by flashing it onto a micro SD card and plugging the card into the onboard slot. Imagine running a mini version of your Linux system right within your microcontroller project. It's like having a tiny computer on your circuit board. Linux can operate the familiar Arduino peripherals via the Wiring X library. Wiring is a library that had been around for quite some time. It is the HAL from which Arduino evolved. Conventions such as pin mode and digital write come from this library. At the time I produced the first version of this video, June 2024, the Wiring X library was not yet available for the 256 meg flavor. But here's the cool twist. The 700 MHz core supports Arduino. This means you can program it using the Arduino IDE, which is super handy if you're transitioning from other Arduino projects. It's like speaking a language you already know, but in an exciting new context. Programming the Milk v isn't just about power, it's about flexibility. You can actually run the Linux and Arduino cores simultaneously, as long as you don't have them talking to the same I/O peripherals at the same time. Need more control and want to use Linux libraries? Put that code on the Linux core. Prefer the simplicity and community support of Arduino. Upload your sketch using the IDE and it will be running on the Arduino core. It's as simple as that. So how do we communicate with all these cores? There is only one USB Type-C connector on the tiny board. Milk v has leveraged the power of USB to perform multiple services. When you connect the USB to your Linux computer, you will find two ports available, a serial port at /dev TTY ACM0 and a USB Ethernet connection. The Arduino IDE need to be directed to the ACM0 port for uploading purposes. To talk to the Linux kernel, you will need to use SSH. PuTTY does a good job. To upload code to Linux, you can use SCP. The IP address is 192.168.42.1. Both of these ports are actually connected to the Linux core. To get debug output from Arduino serial, you will need to connect a USB to serial adapter such as an FTDI or CP2102 to the UART3 pins on the Milk v board, pins 6 and 7. At this point, I want to note that the first time I tried to upload from the Arduino IDE, I got a serial not found error. This was cured by installing the PySerial module into Python, by typing pip3 install PySerial on the command line of my Linux computer. Now, let's roll up our sleeves and code a simple example. Suppose we want to blink an LED classic, right? With the Arduino core, it's just a few lines of code. You set up the LED pin for output, write a high signal, wait a bit, then write a low signal and repeat. Easy peasy. But with the Linux core, you get to dive a bit deeper and use the Wiring X library. It feels more hands-on and hacker style, which is incredibly satisfying. It should be noted that, out of the box, the board flashes the blue LED using the Linux core. To use Arduino to do this, you will need to change the name of the Linux bash script so that Linux will not find it at boot time. So whether you're looking to experiment with Linux commands on a micro scale, or you want the friendly, familiar environment of Arduino, the Milk-V MCU gives you the best of both worlds. There are also rumors that it could run MicroPython. Alright folks, that's a wrap for today. I hope you're as excited as I am to get your hands on the Milk-V and start tinkering. Whether it's the 64 meg or the 256 meg version, Linux core or Arduino core, the possibilities are endless. Happy coding, and remember, the only limit is your imagination. Catch you in the next video. Fellow Canadians can find links in the description to obtain one of these boards.